Hi, everyone. My name is Tanvi Thallapalle, and I am thrilled to have this opportunity to share my passion for sustainable solutions with you. My project focuses on developing biodegradable sorbent materials for oil spill remediation using agricultural waste, things like orange peels, pomegranate husks, and kenaf fibers. Oil spills are a devastating global problem, impacting marine ecosystems, wildlife, and coastal communities. Traditional cleanup methods often have their own environmental drawbacks, and I wanted to find a better way. Growing up in Kern County, a region heavily involved in both agriculture and oil production, I have seen firsthand the complexities of balancing economic needs with environmental responsibility. The devastating Huntington Beach oil spill was a pivotal moment for me. Seeing the blackened waves and struggling wildlife solidified my determination to find a more sustainable approach. Initially, I started small, experimenting with readily available materials like paper towels and cotton pads. But I quickly realized they weren't practical for real-world scenarios. This led me to explore agricultural byproducts, which are abundant, biodegradable, and often discarded as waste. The idea of turning waste into a resource was incredibly exciting. Through rigorous experimentation and data analysis, I've uncovered some truly promising results regarding the effectiveness of the natural sorbents. I've broken down my findings into three key areas, visualized in the charts I'm showing you. Let's first look at the overall oil removal capabilities. Chart 1 illustrates the volume of oil removed from a simulated oil spill after 2-minute soak time. As you can see, the kenaf biopads were remarkably efficient, removing 92 out of the 100 ml of oil. This demonstrates their potential for rapid containment and cleanup, especially in larger spills. The combination sorbents, blends of kenaf biopads with orange peels or pomegranate husks, also performed well, removing 65 ml. While orange peels and pomegranate husks individually removed 24 ml, their real value comes in the blended applications. This data suggests a tiered approach. Kenaf biopads for larger spills, combination sorbents for medium-sized spills, and the orange peels and pomegranate husks potentially for smaller, more localized incidents. Next, oil recovery is crucial for both sustainability and cost effectiveness. Chart 2 details the percentage of oil reclaimed from each sorbent after the simulated cleanup. Interestingly, while the kenaf biopads were the most effective at removing oil, the orange peels and pomegranate husks individually yielded the highest percentage of reclaimed oil. This suggests that while kenaf might be ideal for initial response, the other materials could play a significant role in long-term recovery efforts, maximizing the use of the reclaimed oil. Finally, Chart 3 provides a crucial metric for practical application: oil sorption capacity per gram of sorbent. This data point is essential for determining the amount of sorbent needed for different spill sizes. The kenaf biopads again demonstrated superior performance, absorbing over 4 grams of oil per 1 gram of sorbent. This high sorption capacity, combined with their rapid absorption rate, makes them incredibly efficient for large-scale cleanups. The chart also allows us for a cost-benefit analysis, as we can compare the cost and availability of each material against its absorption capacity to determine the most economical solution for a given scenario. These results were incredibly encouraging. My trials demonstrate that these natural sorbents can absorb between 0.25 to 4 times their weight in oil, and they need only 2 minutes of soak time. The fact that we can recover between 11% and 55% of the absorbed oil and reuse the sorbents after drying further strengthens the case for their practicality and sustainability. These findings highlight the potential for these sorbents to be a game changer in oil spill cleanup. Of course, the research process wasn't without its challenges. One of the biggest hurdles was the inherent variability in agricultural waste. Moisture content, fiber density, particle size, all these factors can impact absorption. To standardize my testing, I implemented strict drying protocols and processing methods. Another challenge was simulating real-world marine conditions. I used seawater from Huntington Beach and even devised a system using mesh coffee filters to mimic wave action in my experiments. Each challenge pushed me to think creatively and refine my approach, strengthening my understanding of the scientific process. This project has significant social relevance. Effective oil spill cleanup is crucial for protecting our oceans, marine life, and the livelihoods of communities that depend on them. My research offers a sustainable and cost-effective solution, particularly for remote or resource-constrained areas. Imagine a coastal community being able to use locally sourced agricultural waste to clean up a spill. That's the kind of impact I hope this project can have. Furthermore, by repurposing agricultural waste, we are not only addressing oil spills, but also promoting a circular economy and reducing food waste. I am incredibly excited to continue this research. My next steps include optimizing the oil recovery process to maximize the reusability of the sorbents. I also want to investigate the long-term biodegradability of the materials in real-world marine environments. I am also exploring partnerships with local farms and organizations to develop a scalable implementation plan. Ultimately, my goal is to translate this research into a practical solution that can be deployed quickly and effectively in the event of an oil spill. This project has been an incredible journey of learning and growth. It's taught me the importance of perseverance, critical thinking, and the power of interdisciplinary approaches. More than anything, it has solidified my passion for using science to create a more sustainable future. Thank you for taking the time to learn about my project. I believe that science has the power to address some of the world's most pressing challenges, and I am committed to being a part of that solution. I am excited about the potential of this research to make a real difference, and I am grateful for this opportunity to share it with you. Thank you.